Okay, so in this part 2 of our video regarding compressor, let's talk about the parameters involving compressors. So first, we have suction pressure. So generally, we denote that as P1. So this is the pressure measured at the inlet of compressor. So next is the discharge pressure. Pressure or P2, pressure measured at the discharge of compressor. Also, suction temperature. So T1, temperature measured at the inlet of compressor. And molecular weight of the gas or air. So MW, this value depends on the type of gas. So for air, it is 30. 5, adiabatic ratio for specific heats. K. So this is 1.39 for air. Now we have a standard rate of flow. So usually given naman to. So QSTD expressed in cubic feet per minute or cubic meter per minute. Minsan gumagamit din ng compressibility, Z. So use 1 pag hindi given or for estimating. So ano ba yung mga kinu-compute? Ito, pressure ratio or ratio of compression. So simply it's just P2 over P1. Also, we need to find out the required head for that particular compressor. So it is the energy required to move unit mass of fluid from one point to another. So generally expressed in feet. So or pound force feet per pound mass. So pound force equal to pound mass. So magkakancel lang naman yan. Kaya magiging feet. In metric, pwedeng meter or kilojoule per kilogram. So ito yung formula niya for head. Next, we have actual flow rate at compressor inlet. So using the standard rate of flow, QSTD, we can compute for the actual flow rate. So this is denoted as QA. Also expressed in ACFM. So actual cubic feet per minute. Ayan. So at a given standard pressure and temperature. So standard pressure natin, atmospheric is 14.7 psi. For temperature, usually nasa 60 Fahrenheit. 50 to 60 Fahrenheit. So, ito yung formula ng actual flow rate. Yan. So, given yung standard pressure and temperature, and also yung measured temperature sa inlet and pressure sa inlet. Next is the mass flow rate. So, you just have to convert the standard rate of flow into pound mass per minute. And so, we have this conversion factor. So, 1 pound mole, so English unit ito ng mole, is equal to 379 cubic feet. And so, you can try to convert this. So, yan yung conversion factor ng pound mole to 379 cubic feet. So, also, you need the molecular weight. So, for air, this is 30 pound mass per pound mole. And then, yung cubic feet per minute, ma-convert mo into pound mass per minute. Or in English, kilogram per minute. Next is syempre yung power required to operate the compressor at a given efficiency. So, horsepower. So, HP is equal to mass flow rate multiplied by the head divided by the conversion factor for foot-pound force per minute per HP. So, 33,000. And divided by efficiency. So, kaya siya divide efficiency kasi kung ano man yung power required to operate the compressor, mas kailangan mo ng mas mataas na horsepower. Dahil meron kang losses sa motor, frictional losses. So, kailangan mong i-divide yung efficiency which is less than 1. So, mas mataas yung compute mong power required. Also, we have discharge temperature T2. Ayan, so, involved din yung efficiency dito. Ayan, so, ito yung formula niya. Then, let's try to solve this problem. So, with the given data, P1 is equal to 3 inches mercury vacuum. So, kailangan natin itong subtract sa atmospheric pressure to convert into absolute. P2, the discharge is 15 psig. So, gauge to. So, we need to add 14.7 psi. Molecular weight for air is 30. K for air is 1.39. Compressibility is 1. Inlet temperature is 100 degree Fahrenheit. Also, the standard flow rate of 504,000 cubic feet per minute. Binigay din yung standard pressure and temperature and the atmospheric condition. So, ito PSI absolute ito. Then, atmospheric condition, so same lang naman to sa standard. So, 14.65 PSI. Now, with this given data, let's compute for pressure ratio, head, actual flow rate, mass flow rate, power required, and discharge temperature. Okay, so let's try to solve the problem. So we were asked to find for the pressure ratio. So solve muna natin yung pressure ratio. Okay, so 1 P2 over P1. So P2 is 15 psig. psig. So kailangan natin magdagdag ng 14.65 dahil din yung atmospheric condition. All over P1 which is 3 inches mercury. So, paano ba tayo convert? So, we have 3 inches vacuum. So, negative 3 inches Hg times 29.9 inches Hg, 14.7 psi. Vacuum pa lang to, so we need to add the atmospheric pressure. 65. So finally we have 2.25. So ito yung pressure ratio. Next is yung head. So ano ba yung formula ng head? Head is equal to Z times 1545. So huwag ko nalagay yung unit divided by molecular weight times yung T1. So temperature 1 times K over K minus 1 times the quantity. So yung pressure ratio na P2 over P1 raised to K1 minus K. K minus 1 all over K minus 1. So yung Z is 1 times 1541 divided by 30 for air. times yung T1 natin ay 100 degree Fahrenheit. So, convert na natin to Rankine. So, kailangan Rankine yung unit ng temperature. 100 plus 460 times 1.39 over 1.39 minus 1 times pressure ratio, lagyan na natin yung 2.25. Ito raised to sa 1.39 minus 1 over 1.39 minus 1. So, finally, yung head natin ay 26,276 feet or foot-pound force. Foot-pound force per pound mass. So, meron na tayong head. So, actual flow rate naman. So, number 3, QA is equal to Q standard. So, standard flow rate multiplied by T1 over P standard times P standard all over P2. Ayan. So, may nakalimutan akong ilagay. Hindi pala to per minute. So, this is per day. Per day yan. So, let's solve for actual flow rate. So, QA is equal to 504,000 feet cube per day. So, convert na natin yan into minute. So, 1 day is equal to 1440 minute. Then, ano pa? Yan. Substitute the temperature. So, times, yung T1 is 560 all over, T standard natin is 60 degree Fahrenheit. So, 460 plus 60 is equal to 520. So, lagay natin dyan 520. Multiplied by standard pressure. So, 14.65. All over the discharge pressure, which is sorry, hindi to P2. Dapat ano yan, P1. P1 yan. Okay, so si P1 ay yung negative 3 inches mercury, that is equal to 13.18 PSIA. 13.18 PSI absolute. So, compute for actual flow rate. So, we have 416. ACFM. Okay, so next is the mass flow rate. Okay, so 4. So mass flow rate m dot is equal to Q standard times yung conversion factor natin, which is MW over 379. And so M dot is equal to So Q standard is 504,000. Pero per day yan. So feet cube per day. So convert ulit natin to minute. 144 minute. Okay, so times molecular weight ng air is 30 divided by 379 feet cube per pound mole. So finally we have mass flow rate of 27.7 pound mass per minute. Okay, so next is the power required. So number 5, HP is equal to mass flow rate times head divided by 33,000 times the efficiency. So horsepower natin is equal to 27.7 pound mass per minute times the head, which is times the head 26,276 foot pound force per pound mass, and all over 33,000 foot pound force per minute per horsepower times, okay, nakalimutan natin ilagay yung efficiency dito. So K is efficiency 60%. Yeah, 60% yung efficiency dapat. So we have 60% efficiency. Okay, so 0.6. So finally, ang horsepower required to run the compressor is 36.76 HP. Now, we need also the discharge temperature. So 6 T2 is equal to T1 times P2 over P1, formula kanina, P2 over P1 raised to K minus 1 over K minus 1 sa taas all over efficiency plus 1. Okay, so let's solve. Substitute natin yung values. So T2 is equal to, yung T1 natin is 560 Rankine. So itong P2 over P1, solve natin ito, 2.25 raised to 1.39 minus 1 all over 1.39 minus 1 over 0.6 plus 1. So T2, so 7 and 8 Rankine. 7 and 8 Rankine. So subtract tayo ng 460 to convert into Fahrenheit. 338 degree Fahrenheit. Okay.